All right, so next we have a think, pair, share. And of course, in a classroom, this is where you'd work with a partner to answer all these questions. Go ahead and pause and give this a try yourself. And just resume this video when you're ready. So now I'll assume you're ready. This is about allergic reactions, acute allergic reactions in U.S. emergency department visits. So between 2001 and 2005, the frequency of a U.S. emergency department visits for food-related acute allergic reactions occurred every 3 minutes. For this problem, suppose the standard deviation is 0.5 minutes and the sample size is 100. Question one, find the median, the first quartile, and the third quartile for the sample mean time of emergency department visits for food-related acute allergic reactions. Question two, find the probability that an emergency department visit occurs on average between 2.75 and 2.85 minutes. Question three, find the value that is 2 standard deviations above the sample mean. And question four, find the interquartile range for the mean time of emergency department visits. All right, first let's work on question one. So find the median, the first quartile, and the third quartile for the sample mean. So remember, the median is the 50th percentile. The first quartile is the 25th percentile, and the third quartile is the 75th percentile. All right. And again, let's go ahead and draw. Let's see, I have the full page for this? Okay, that's good. So let's let's go ahead and put down what our given information is. Um, so between these years, this looks like all U.S. emergency department visits. So this looks like a population. And so the mean response time, let's see here, or the frequency, I'm sorry, the frequency of visits to the hospital for allergic reactions is every 3 minutes. So we'll put the mean of the frequency is 3, and the standard deviation is 0.5. So I'm just going to, for this on the side here, just kind of define what this random variable is. So this random variable is the frequency let's see here. The frequency. Don't like that. Let's see here. Let's make this maybe the time between the time between emergency department visits for food-related acute allergic reactions. Okay, and so the mean time for this population was 3, and the standard deviation was 0.5 minutes. All right. And for a sample size of 100, we want to calculate these quartiles. All right, so we have a sample size of 100. And not only are we calculating these percentiles, we're calculating the percentiles for a sample mean from a sample size of 100. So let's go ahead and let's see here. Let's put the distribution for a random variable. We don't know whether it's normally distributed, uniformly distributed, but we really don't need to know what that is because we were given what the mean and the standard deviation was. So that's going to allow us to, let's see here, proceed forwards with calculating our distribution of sample means. And we need to figure out what the mean and standard deviation is for our distribution of sample means. Because only by knowing these things can we then have the parameters we need for each of these different percentiles. So, um, the median, for example, is the 50th percentile, and the first quartile is the 25th percentile, and see, I'm running out of room. Let's do it this way. Because I want to have some room there at the top. Okay, so median, which is 50th percentile. First quartile, which is the 25th percentile. And the third quartile is the 75th percentile. So if we were kind of to draw each of these three on a normal distribution like this, normal distribution curve, then for this first one, the 50th percentile is going to be where the area is 0.5. Well, the area is going to be 0.5 on this value here, which is exactly the mean of our distribution of sample means. The 25th percentile will be some value here on the left where the area is 0.25. And for the third quartile, it's going to be some value here where the area to the left is 0.75. So we have to figure out, these values of K for each of these three. But in order to do that, we need to know what the mean is for this distribution, and we have to know what the standard deviation is for this distribution. We have to know both of those things. So how do we get these from what we've been given? How do we calculate this and how do we calculate that? Well, by what we've learned about the definition of the sampling distribution of the mean, we know that it is equal to the population mean. And we know the population mean is 3. So that's pretty much a done deal there. So we have this value. Now to get the standard deviation for our distribution of sample means, that's the standard deviation of the random variable of our population divided by the square root of n. This value was 0.5 and n was 100. So that's 0.5 divided by 10 is going to be 0.05. So sigma capital X bar is 0.05. And that's the second value we need in order to calculate these values of k in each of these different quantities we need to calculate. So in all three of these, we've been given an area, and from this area, we have to calculate a value. Well, we can do that. We can do that with, an inverse distribution function. So our value of k for the median, our value of k for the first quartile, and our value of k for the third quartile. That's where I'll put my answers. Actually, the value of k for the median, is where 50% of the data is on one side. And we already know what that is. It's 3, right? Because that's equal to 3. So we have that one right off the bat. So what we have to do now is calculate these other two. So let's go to Texas Instruments, and we need to use inverse norm. There we go. We have an area now of 25% for the first quartile. We have a mean of 3 and a standard deviation of 0.05. If memory serves. Yep. Okay, let's bring that back and let's do the numworks calculator. So let me backtrack here. Okay, application screen, we want to go to the distributions menu, go down to normal. Mean of 3, standard deviation of 0.05. And then next. And we want the area to the left, right? Area to the left with an area of 0.25. So we get a value of 2.966 over here with the Texas Instruments. Don't know why it's not moving off of the left for me. 2.966. Okay, same answer. So this is going to be 2.966, which is 2.97. You round it. And now instead of 25% or 0.25, we'll put in 0.75. So we'll do inverse norm, and this will be 0.75. All the other values are the same. 3.0337. Here, I'll just change the area to 0.75. 3.0337. Okay. So that's going to be 3.03. All right. So that's how we calculate the median, the first quartile, and the third quartile in question 1. All right, let's look at question 2. Find the probability that an emergency department visit occurs on average between 2.75 and 2.85 minutes. All right, so let's draw what that looks like. So the distribution of sample means will look like this. It's normally distributed. Let me get rid of those Should have put that in there. Okay, it's normally distributed with a mean of 3 and a standard deviation of 0.05. All right. So what's the area between 2.75 and 2.85? It says find the probability. So it wants this area. So the probability that we have an average time between 2.85 and 2.75. So that's going to be equal to an area under the curve. And so since we're given values, we need to use a CDF function to go from values to the area that we need. So let me do the numworks calculator first. And we can leave all these parameters in. But now we just have to change the area we're looking for. We're looking for the area between two values. So that'll be this second option. And the two values are 2.75 to 2.85. And only leave that up. So I'll come over here and clear this to simplify things. Go to the distribution functions, go to normal CDF. The lower value is 2.75. Upper value is 2.85 with a mean of 3 and a standard deviation of 0.05. Paste. Enter. And come over here. Enter. We get 0.00135. So that's going to be the probability that the mean frequency time is going to be between 2.75 minutes and 2.85 minutes is 0.135%. Okay, so the area here was this value. Okay, find the value that is 2 standard deviations above the sample mean. So the value that we want, we're going to use this algebraic relationship. So this is like the inverse function for calculating a z-score. And let's see, the standard deviation was 0.05. Because we want values above the mean, that'll make this a positive 2. And then the mean was 3. And so 0.05 times 2 should be 0.1 plus 3. That's going to be 3.1. So 3.1 is 2 standard deviations above the mean. Now, let me just, for fun, I know, for fun, right? If instead of above, this had been below the mean, okay, we would have still used the same equation like this. But the difference here is that z would have been -2. And that would have made this a negative 0.1. And when we take a positive 3 and we subtract 0.1 from it, we would have gotten 2.9. So that's the answer we would have gotten had we been asked for 2 standard deviations below the mean. All right. Question 4 is to find the interquartile range. So the interquartile range is equal to the third quartile minus the first. And these were values that we calculated earlier. So the third quartile is 3.03, and the first quartile is 2.97. So that's going to be 3.03 minus 2.97. So that's 0.06, and this was in minutes. So the interquartile range, meaning the middle 50% of time, is 0.06 minutes. It's pretty small. Okay. Yeah, I think that concludes this example. Let me know if you have any questions.